So again, welcome everybody to the Chi at Edge webinar. Chi is, of course, Chameleon infrastructure. It stands for that. And Chi at Edge is a new component of this infrastructure that we're developing now in order to allow our users to experiment in the edge to cloud continuum. So I'm going to present first a few words of introduction, and then you're going to hear from Jason Anderson, who's the Chameleon DevOps lead. And he's going to give a demonstration of how to use Chi at Edge. In other words, how to allocate devices via the Chameleon testbed. Now, some of you may not be familiar with Chameleon testbed, so just a few words of introduction. If I ever find out how to advance my slides, there it is. So Chameleon in a nutshell. First of all, chameleons like to change. So this tells you right off the bat that it's a testbed that likes to adapt itself to your experimental needs. Our users work on projects like designing new operating systems, designing new networking protocols, topics in machine learning, developing new virtualization solutions, and those things cannot be developed by submitting jobs to schedulers. So instead, we give our users the ability to reconfigure resources at a very deep level, on bare metal level. So you can reboot the machine, you can boot it from custom kernel, you get access to serial console, etc. In terms of hardware investment, Chameleon is composed of 3 sites, University of Chicago and Texas Advanced Computing Center. It used to be 2 sites, UC and TAC, but now recently we were joined by another site at Northwestern. And we've got investment in both large homogeneous partitions on both of those sites, but then also investment in a diversity of resources. So we've got ARMS and Atoms for especially interesting for people who work on power management, for example. We've got multiple different clusters of GPUs, and we'll be buying more because there's obviously widespread interest in machine learning. We've got FPGAs, we've got interesting networking hardware, and so on and so forth. One thing that makes Chameleon different than previous computer science testbeds is the fact that we build on mainstream open source infrastructure called OpenStack, right? And while you may know OpenStack as something that deploys virtual machines, we use it in a configuration where it reconfigures resources on bare metal. Working with mainstream open source infrastructure has a range of advantages. Advantage number 1 is very familiar to both users and operators. Other advantage, there are thousands of developers working on OpenStack and thousands of code reviewers, which is equally important, right? So we often leverage features that the community produced, right? We just integrate them into the testbed and it's available for our users. Another important advantage is that if we contribute to OpenStack, that multiplies our broader impacts, and we get to work with open source community on those contributions. And finally, something that we realized just recently is that one cloud is very much like another cloud. So working with something that is established in the mainstream means that there's a lot of tooling that allows you to convert from one cloud to another. So that means that if you want to run experiments over Chameleon and commercial clouds, that now becomes much easier because there's tooling that converts the images, that converts the orchestration templates, and so on and so forth. And here are some statistics about availability of Chameleon. Is we started in 2014 and were recently extended till 2024, till the end of that year. We've managed to serve almost 6,000 users at this point, who worked on more than 700 projects, published almost 400 papers, and come from 45 countries, which is important, right? So it's not just for the US, it's open infrastructure that has users everywhere. And like I said, 3 more years to grow. So how do we now take something that is effectively a cloud computing research testbed in the data centers? How do we take it outside and how do we give it an edge? So the first question is, what does an edge testbed look like? And we don't have a full answer to that question as of yet, right? Because edge computing is a dynamically growing, dynamically developing field, and the answer changes, right? Every day we learn about new things that users want to do. But when you design a test bed, one of the first questions that arises is how are you going to provide sharing and isolation, right? So how are you going to ensure that users get their own experiments and that nobody is encroaching on their experiment? And of course, you want to be as flexible in that space and as inclusive in that space as possible. So bare metal reconfiguration is fantastic. But containers and virtual machines are also a viable solution. In this case, since we're working with edge devices, bare metal reconfiguration is not always possible because many of them don't support IPMI and can't be reconfigured at bare metal level. So we chose containers as the unit of isolation, right? So in other words, when you come to Chia Edge, you're going to be doing something that is similar to what you're doing on Chameleon, but instead of bare metal configuration, you're going to be deploying containers on those devices. So secondly, when you come to Chameleon, you choose a site, you work on either resources in either Chicago or at TAC or at Northwestern, but these edge devices could be anywhere. And they could be in particular specific to locations. So what we decided to do is create a virtual site. And when you experiment with Chia Edge, you come to this virtual site that is of course located somewhere, but it doesn't matter where it's located, right? You come to the virtual site, you authenticate with federated identity, and based on that authentication and the corresponding authorization that ties you to a project, you deploy containers. Another thing that we really realized, though, is that, well, we can run a range of experiments on on devices that we provide, but it's also very important for people to be able to add their own devices, because edge devices, it's not just the device, but its deployment context matters very much, right? So we are currently working on an SDK that will allow you to add your device to the testbed and make it shareable, or add your device to the testbed and not make it shareable, right? Sometimes you want to share the device with your students, with your collaborators, and sometimes you don't, right? So we're going to provide for both cases. This is still in development, so what you're going to see today is going to be those first bullets, roughly speaking. But if you are in a situation where your research requires you to add the device, please talk to us as soon as possible, because we can help you configure your own device, and we're in fact already working with a few groups to do that, right? So we will handle this right now on a case-by-case basis. The SDK will become available later this summer. And the last thing is, we would like to invite you to join us in the summer on the Edge, because our hope is that we will manage to run as many different experiments as possible, and we will learn from that what capabilities are actually needed. So please treat Chia Edge as a strawman. It's a reliable and secure strawman and all those good things because it's been built on top of mainstream infrastructure, but it's something that is still developing in terms of the interfaces that we'll give you. So a few words about how we built Chia Edge. Of course, in order to build something like this quickly and then be able to work with the community on defining it better, we wanted to leverage existing investment. And we, of course, went to OpenStack again. We're using part of OpenStack that is configured to deploy containers rather than do bare metal reconfiguration, but we had to adapt it to work on edge devices, right? So OpenStack that deploys containers was still developed to work in the data center, and we had to open it up, look at the assumptions that it's making about being in the data center, carefully choose which ones we had to invalidate and re-implement, and which ones we were willing to live with for a while, right? And this is your OpenStack for Edge that we developed. And then we combined it with user-facing Chameleon tools, such as access via federated identity and Jupyter integration, right? So that allowed us to push something out very, very quickly. Important thing to know, Chia Edge is in preview and it will remain in preview in the foreseeable future. This means that it's moldable, that we are still developing the feature, and you can tell us what you like and what you don't like, and maybe we will need to change our approach completely. Important thing also, please do sign up for the to the mailing list, Chameleon Edge users. We will be doing support via this mailing list rather than via normal Chameleon by the ticket channels, just because we're also trying to develop a community resource, right, where users can look at previous posts in the mailing list and find the answers themselves. So, and we're also, this is a very new feature of Chameleon, right? So we would like to do that in a more direct manner. A few pictures about shared edge development. Like I said, we're moving out of the data center, which you see here on the left, to something that Jason, who you will hear from shortly, built on his kitchen table, right? And as you can see, we're building this in a hurry, so cats and other domestic animals were pressed into service, and we're helping out. What will it look like to you as an experimenter, right, when you come to the testbed? So if you think about your standard experiment workflow where you come with a hypothesis, then you discover resources that support that, that will allow you to validate that hypothesis, hopefully edge devices, then you allocate them, then you configure them, and then you run your experiment. So what we support is a resource table and an availability calendar, right? So you're able to go to a web page and see what resources are available and when. We give you the ability to make advanced reservations or get the resources on demand if they are available. We provide expressive interface. So you can say, I want a Raspberry Pi, or I want an NVIDIA Nano, right? But you could also say, I want this particular Raspberry Pi, right? Because I know where it's located, it's on my drone, and it's important for me to allocate it there, right? So you can allocate by type, you can allocate by special device. Reconfiguration will happen by container deployment. You'll be using Docker Hub images, and there's a pointer to that from our instructions. If you snapshot them, and then you will have Jupyter integration. You will rely on Jupyter integration to do orchestration. And you can, of course, do orchestration via scripting tool if you so choose. All these testbed functions are available via 3 different interfaces, via a web GUI, via command line interface, and via programmatic interface in Python that has been integrated with Jupyter. And for all of them, the authentication is via federated identity. In other words, your institutional credentials, but it could be also your Google account. You can log into Chameleon with your Google account as well. A quick side-by-side comparison for Chameleon users, so for people who are already familiar with Chameleon. In Chameleon for bare metal, we do advanced reservations for bare metal machines. Shared edge, we do advanced reservations for edge devices. Bare metal reconfigurability versus container deployment. And then we have heterogeneous collection of interesting hardware in our data center offering. But for our edge devices, we've got a collection of interesting hardware and context. You get public IP capability, just like you do public IP assignment capability, just like you do in our bare metal offering. You get Jupyter integration. And last but not least, in Chameleon offering right now, or up to now, all the resources were owned and operated by us. But now you will be able to add your own devices. So with that, I'm going to stop my slides and stop just talking. I think that you would all like to see this in action. And so I'm going to turn it over to Jason, who will give a demo of what this looks like in practice.
Okay, so just move some stuff out of the way here. Okay. So yeah, I'm going to give a demo of a few things. And just as a first step here, for those of you who are not familiar with Chameleon, I wanted to give a really quick rundown of sort of how you get started. So if you go to www.chameleoncloud.org, you'll hit our main site. And the first thing you can do is log in. As Kate mentioned, we support login via federated identity, which supports also Google account and Orchid. And if you don't have an account yet, you can sign up. Otherwise, you can just log in. I'm already logged into my UChicago identity provider, so it's just going to zip me through. When you get here, if you're new, you might not have any projects. And only PIs are allowed to request projects. So if you know somebody who is your PI, you can ask them to add you. If you do have PI status, then it's very simple to create a project. You give us a bit of information about what you're trying to do and how you're going to use resources. And this would apply for Chia Edge projects as well. And then we review it, and typically that happens within 24 hours. Back here, once you have projects, you can manage them. And if you're a PI, you can add and remove people to the projects. We have some nice improvements coming here to make it a bit easier. But you can, as you can see, sort of manage the availability, the memberships, and you can see sort of how much of your allocation you've used. Now, it is required to have an allocation to do most stuff on Chameleon. And that includes the Jupyter interface, which I'm going to show later. So if you try to use some stuff and you get errors that you're sort of forbidden, or it's not working because you're not part of an active allocation, that's what this means. You should ask your PI to add you, or if you are a PI, you should apply for a project. So that's a quick rundown, and we're going to be talking about today, obviously, is Chia Edge. And you can click this button under the experiment section to learn more about what Chia Edge is. We have a little summary page here with a lot of links that you should peruse at your leisure. Importantly, the mailing list sign up. I think Mike shared a link to that already in the Zoom, but definitely check that out. And then we also have a page that describes a bit about the hardware that we have so far. And I'm going to talk about sort of upcoming additions there. And what else we got here? We have also a very thorough and handy documentation page that kind of goes over what I just told you about, plus what I'm going to tell you about right now. So you can access the graphical user interface. I'm just going to give you a sense of what this looks like. So when you log in, it's like single sign-on, so it just uses your existing credentials. And you're going to land in something that looks like this. If you've used Chameleon before, it'll look quite familiar. If you've used OpenStack before, it'll also look familiar. It's just green and has a nice Chameleon logo in the top. But this is basically a full-fledged user interface for managing cloud assets. And you can reconfigure it very similar to it's quite similar actually to AWS, just with a smaller feature set. And a lot of the abstractions carry over. And what we're going to be talking about today is the container functionality. And just to give you a sense of how it works. So I'm in here, and currently the site is actually configured to allow sort of an on-demand container to be launched. But we're going to be talking about reserving a device. And if you really want to be guaranteed to have a device, you should reserve it. And okay, so I'm going to launch this image. You just can use the name of any Docker Hub image. Docker Hub you can get to at hub.docker.com and find something that will work for your target device. And if you've used Docker, a lot of these options are really going to be familiar as well. It's pretty much exactly what Docker supports. So you can do things like specify sort of CPU and disk to allocate to the device, to the container if you're interested in limiting resources. You can attach networks, and I'm going to use like a default network that we've created for you. But you can also create your own networks, in which case your containers will be communicating over an isolated link, isolated network rather. And you can also customize security groups. So by default, your containers are not exposed to the internet at all, but sometimes this is desirable. And we're going to do a demo showing one such case. And that's a case when you can use security groups to allow various port traffic to come in and to leave your container. So that can be interesting if you're playing with that. And then finally, you have sort of standard stuff. You can set the working directory, set environment variables, and so on and so forth. I'm just going to try just launching this now. So this is, so currently in Shed Edge, we have it set up with like a few different Raspberry Pis, and we're bringing Jetson Nanos on board sort of imminently. And what this is doing, so we have like a cluster of Raspberry Pis down the road. I'm in my apartment now, and we have them set up in an office at University of Chicago. We also have kind of a satellite location near Rutgers. And it's scheduled a container on one of these Raspberry Pis running in some sort of remote area. And importantly, these Pis are not in the data center. This can be deployed really anywhere to a device that has internet connectivity. That's really the only requirement for having a device host such a container. So it has started. We do assign it a private IP address on a sort of on a private network, private to the container. This is not something that's exposed, and it just allows containers to talk to one another. We're able to do this even if your device, your Raspberry Pi or something, doesn't have an IP address. We're still able to connect them in this way. So you can view the logs if there were any. In this case, my container is just launching a shell and there's no logs yet. And there's not a whole lot to do right here. It's sort of the container is running, and if you want to connect other containers to it and communicate, you can. But there are some little things you can do to manage the life cycle. You can stop, restart, rebuild, kind of similar to if you're managing a virtual machine, but it just is things that are more relevant to a container. One interesting thing is you can run one-off commands, which is useful for maybe doing some like just a little diagnosing of something that's going on or just verifying something. In this case, I can just check that I can ping the internet from my container, and I can. Very good. Anything else I wanted to say about that? I don't think so, but before I go into the sort of more advanced part of the tutorial showing the Jupyter interface, I did want to point you to this reservations thing, because as we mentioned, one of the sort of main aspects of Chameleon is that you reserve resources for your exclusive use. So there's a number of benefits, notably performance isolation. You just have more control over your environment. You don't have these noisy neighbor issues, and you're able to isolate your workloads. As well, it's nice when you can allocate an entire device to something. So you can have multiple containers that you're running on a single device, maybe one container that's sort of taking up all the resources. You can kind of choose how you want to do it, but the reservations you make are for devices, physical devices. We have a calendar here that tells you when the devices are reserved. And so this can help you get a sense of like, oh yeah, there's a lot of like Raspberry Pis available right now, and these two are reserved by me before the webinar. And so those ones are unavailable until about a day and a half from now. And you can schedule a reservation ahead of time, which allows you to kind of ensure that you're going to have access to something, especially when we're kind of building out the selection of devices. It's pretty important, but also just important in general for these sort of research infrastructures, so that you know that you're going to have resources for your experiment before a paper deadline or something like that. Okay. Cool. So let's jump now into something a little bit different. So another interface that we have on Chameleon, as Kate mentioned, is the Jupyter interface. And I'm going to show that now. I'm going to show it, though, just by way of this thing that we have called Troby. So Troby is basically a collection of Jupyter notebooks that have been created by us and by other users that illustrate how to run some sort of experiment on the testbed. And anyway, so we have a user guide for Shed Edge, and I'm going to be using this to sort of show off the functionality we have here. When you open one of these, it will open it up into an actual Jupyter application server that's assigned just to you. And so you have all your the files that were a part of that experiment open here. And I'm going to show you kind of why and how this is a kind of an interesting way to use the testbed. So the the Jupyter application itself is quite intimately connected with Chameleon. So like when you log in, it knows who you are, and it will put your credentials inside of the Jupyter application so that you can call APIs using the Chameleon SDK or the Chameleon library, which we have here. And you can use it to sort of request things on the test bed as yourself. So it's kind of like you take a lot of the authentication complexity out of this, and you can use interfaces without having to muck with all of that. It's built in. You do have to say like sort of what resources you're interested in. We have several different sites, including the bare metal sites. In this case, we're going to be using the Edge site, and I'm going to be using a project that we have internally. Your project will be something like CHI, blah, 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 or whatever. But yeah, we're going to be using this one for this. And I'm going to just import some sort of libraries we've created to make all of this next bit easy. So the first thing that we're going to show is that it actually is possible to make reservations for these edge devices now. So I'm going to try to give this a shot. I've already made one reservation in case this falls through, but let's try it. So this is actually requesting from Chameleon system to give me a reservation for 2 days for 2 devices that are Raspberry Pi 4s, is sort of what that's expressing. And you can maybe see, I don't know, it's not going to do it. But you can, if you're inside of this, you can click Shift and Tab to sort of get some information about what parameters you can put in here, as well as we have pretty extensive documentation at python-chi.readdocs.io. And I believe that's linked as well from the Chi at Edge section. So we've got lots of docs there that you can peruse. Okay, and yeah, there it came up. Great. So that actually completed. So that's great. I can verify that by going back to the Edge site. Any changes that you're doing inside of the Jupyter Notebook, you should be able to see them reflected on the site. And I can see that here I've got my lease. My lease is active, and it's all good. So very good. Now we're going to launch our first container against one of these devices that we've reserved. So this is basically doing what we just did in the GUI, but with a Python interface. So it's very programmable. I'm going to be passing in some parameters that are a little bit more complicated than before, because what I'm going to try to do is launch a container that actually serves a web server. And so I'm going to use a Python image from Docker Hub that's compatible with Raspberry Pis because it's ARM architecture. And I'm going to expose port 8000. As I said before, ports are not normally exposed on containers. So you have to kind of tell it, like, please expose this port. And then I'm going to serve the website on that port. So let's do that. This can take a little bit of time if the way it works is that, it has to download the image onto the device. And this can take a little bit if the image is not already located on the device. In this case, either it downloaded it already or it was already there. So it's just it created the container, and now we wait for it to kind of start up. And hopefully it does. Good. Okay, so the container is running. And once again, I don't know why I closed these windows. I can see that my first container, that was one I just launched, that one is running. Very good. Now we can do a lot of the same stuff that we can do with the GUI, but we can also do actually more stuff than we can do in the GUI with the Python interface. Aha. So this is why using the Python interface is quite nice, as well as the CLI interface. We can still do the same thing, like executing one-off commands. And it's also very easy to associate a public IP address. Now, this is something that is very important because, as I said, these containers are not exposed to the internet normally. So I have a web server, but I can't access it. What I need to do in order to access it from home, from my apartment here, is to assign a public IP address to it. So I can do that. I just have Now, if I go to that public IP address, it's actually routing that request to my container that's running, wherever it is running from. And there's not much to see there because there's kind of nothing in that web server, which is good. It's not serving any sensitive files or anything. Now, let's make it a bit more fun by uploading some content there. So this is kind of where the Jupyter bit is pretty interesting, because I can have this folder here locally to my Jupyter application, call it web server, and I've got this simple little HTML file that just says hello. And I'm going to upload that to the directory that I'm serving this website from. And this will actually upload it from here, up to the container, loads it into the container. And now, if I reload this, I can see that this file is here and it says hello. So that's pretty cool. And just to prove it to you, I'm going to update this. Here's something else. Save, rerun, refresh. Very cool. So I can pretty rapidly iterate on doing stuff if I'm like managing files that I'm uploading and placing on the remote container. As Kate mentioned, it is also possible to snapshot these containers. So I just uploaded stuff to that container. Now, if I want to snapshot the current contents, I can also do that. I'm just going to name this differently because I think I already have one that I was doing before. And what this is doing, it'll actually just take the file system of the container and store it as a new glance image. It's not really important to know that it's called glance, but it's basically a parallel system it's not uploading it to Docker Hub or something. It's kind of storing it internally at Edge. But you can use the ID of that thing later instead of a Docker Hub image to then like reinstantiate that snapshot. I'm not going to show that process, but I'm just going to mention that it is possible. Okay, so I think that's all I wanted to do with that container. I'm just going to tear it down now because there's no reason to keep that running. And now we're going to move on to something a little bit more complicated / more interesting. And this will give you a little bit more of a sense of a wider variety of things that are possible. So now we're going to launch 2 containers instead of 1, and we're going to make them talk to each other. This is going to be a kind of a real-time communications experiment where we have one container that's acting as a sort of message receiver, message broker, and it just receives messages from another container that's just sending them every so often. So we got one container that's kind of just beep, beep, sending messages. Another container just sits and listens and collects them. And then we're going to, from Jupyter, connect to that broker, and it will just pass them on to us then from the publisher when it gets them. This is using MQTT under the hood, which if you've done some Edge or IoT experiments, you might have already used something like that. Just more of a technical detail. The main concept is we've got these 2 things, and we're going to be connecting to one of them. So to get it started, I'm going to launch the MQTT server. Should have done this before because now I don't have a whole lot to say right now. But I guess I can say that it is a bit different. We are doing a few new things. We have a different image. We're exposing multiple ports because MQTT has 2 different ports, one for WebSocket connectivity. It's not really that important. But what is cool is one really common thing you do when you're launching Docker containers is you pass mounts to them. And the reason that this is common is because you might not want to bake in your configuration into your Docker container. You might want it to have it be kind of a generic container that can then change its runtime behavior based on a configuration file that you pass to it when you start it. Otherwise, you end up having to stamp out tons of container builds with like whenever you tweak a little configuration element. So as a result, it's quite common to have the container expect to find a configuration file somewhere, and then you provide that when you launch it. And that's what we're doing here. In this case, it's kind of cool because we're taking it, again, from Jupyter. So I've got this, we're using this MQTT technology implementation called Mosquito. It's just a simple message broker. And we're going to configure it with this file. And we're going to then pass that file and tell it to mount it at a location that it's expecting to find. And the other thing is that, notice, I'm telling it to launch it against one of my reservations. So this is saying like, yeah, use one of the devices that I reserved to launch this container. You can also, when you're creating the container, pass in a host variable to say which specific host in the reservation do you want to launch it on. And that just lets you have a bit more control if you've got a few different devices in play, and they should have different roles. Okay, so that's all. In the meantime, I did have enough to say, as it turns out, and that's all done. It has an IP address, very good. Now, we're going to start the other one, which is the one that's going to be sending data to that central broker. In this case, there's a few, one or two different things. We're taking advantage of the fact that you can pass environment variables, which is another common way to configure a container, especially if the configuration is relatively small and it's just like one or two little values and not like a file that you need to provide. So in this case, I'm telling it that, yeah, you can find the server that you're going to talk to on that private IP. Because those containers now, they're on the same network. They're able to exchange traffic, not over the internet effectively, like it's sending it over a private channel. That private channel may, in practice, be extended over a long sort of distance, but the main sort of thing here is that they're connected on a private network to them. And the other thing is that normally this Docker image is going to want to start a server to listen for those events. And in this case, we don't want that, because I actually want it to instead publish some messages. And so I have this other script called publish stuffs. And what it does is it uses a utility that kind of comes built into that Docker image that allows you to publish. And now you can see why I set that environment variable, because I'm going to be using it here. And so what it's doing is it's just publishing messages to a sort of a topic. In this case, that's sort of like a bucket where the messages go. How often, and then what the script does is it just sort of spits out a random number every once in a while and puts it in there. Okay, and that is, in the meantime, done. So now we come to the part where we're going to actually start pulling that data down into the notebook. And again, in order to do this, this Jupyter application is external to my experimental network. And so in order to reach in there, I do have to assign a public IP address. In this case, I'm going to assign it to the server. So I'm going to be listening to events coming from that broker server. I'm using just a really standard MQTT Python library that's pre-installed inside of this Jupyter application, which, by the way, you are free to install other libraries if you want to. You have control over that inside of this Jupyter application. So if you need something else, you can install it. Then typically you need to either refresh the page or restart your kernel, or depending on what you've done. But in this case, a lot of the common stuff is we try to build in there for you. MQTT is one such thing. So in a little bit of code, I've just connected to that broker over the public IP address. And now, as the final thing, I'm going to just sort of periodically try to pull messages off of that broker, again, over that public IP connection. So Jupyter is calling out over the internet, asking for messages, and then I'm going to print them on a special type of plot that supports real-time updates. Cool, there we go. So it printed out all the data that had been sort of already sent to the broker. And then it's every, once in a while, it's waiting and listening for more events. And then the values that it's printing are the values that are actually being sent from the publisher. And it's supposed to be a random number, but it's using this, I think, very bad implementation of randomness. But the important part is that we've achieved real-time communication here. And I can this is going to just keep going, so I just sort of artificially capped it to check 60 times for messages, but it'll keep doing that all day long. Okay, let's go back here. And I wanted to now just before I turn it back over to Kate, share our roadmap. Actually, this is not going to work, is it? You're not going to see that. Let's just do it like this. Oops. So what we've shown today, and if you're actually at the webinar 2 weeks ago, we showed some of this stuff. But today what we have is, like again, early preview availability, as Kate mentioned, login with federated identity. And importantly, we now, if you were at the last webinar, we did not have yet support for reservations and for single tenant isolation. And now we do. So you can actually find those devices that we have, reserve them, you get access, you can launch containers on them, use them as you wish. Imminently, we will be expanding the sort of number and type of devices that we support, notably with addition of NVIDIA Jetson Nano, which we're kind of ironing out some tricks with their particular distribution and kernel requirements. But you should be expecting that very shortly. At the end of the summer, we've got other stuff that we're aiming to get out, notably having a nice browsable hardware catalog. And just to give you a sense of what that's going to be or what's inspired by, currently the other Chameleon clouds, the bare metal clouds, have a sort of extensive browsable hardware catalog that lists all the devices that exist across all of the sites. And it allows you to filter by sort of coarse-grained classifications, as well as sort of more specific things like, oh, how much RAM do you want? How many threads on the CPU do you need? And we're going to have something like this to enable you to see what kinds of devices there are and what capabilities they have, because I think there's going to be a lot of heterogeneous sort of devices. And with that, we're going to be working on adding support for more of these types of devices and peripherals, like cameras, SDR. But we're kind of interested in what other, especially your feedback on what types of things are interesting. For example, like even bringing this separate network devices or something, is that useful? And then finally, we hope to have a sort of private beta of bring your own device, allowing you to, as Kate said, either share or not share a device that you're bringing to the Cheat Edge environment. And that was it for me. Again, here's another link to that Google group if you haven't seen it a million times already. But that's it for me. I'm going to stop sharing my screen if I can find it again. Yes. Great.
Okay. So we're gonna let Jason catch his breath a little bit. That was a fantastic presentation. Just to add before we go to questions, and I see that Guillermo already has some very good ones lined up there. Before we go to questions, just to add to what Jason said, we are planning various capabilities to release them during the summer, integration with cameras and SDRs and things like that. Or providing the SDK. If you need those capabilities sooner, if you need them now, please talk to us. Tell us about it as soon as possible. We are trying to accommodate every use case that we can as quickly as we can. We're really committed to getting as many experiments on their way as possible this summer. And it's a very important need to us, right? It's very important for us to learn what it is that you want specifically before we invest more cycles into the implementation we have, right? So Cheat Edge is right now it's a straw man. The features can change, the configuration can change, and it's really honestly up to you how it changes. So please do let us know. And back to Guillermo's questions now. He says, do you see Chameleon edge computing surpassing its clusters, assuming a large and increasing adoption in the future? And this is a fantastic question, because this is really not just about Chameleon, but about balance of resources that we use at large, right? So it really does seem that increasingly servers are escaping from data centers, right? And they are multiplying in the wild, right? And I've got this device and I've got this device, and we are increasingly surrounded by them. So I think that what we do in Chameleon will very much follow that trend, right? We'll follow the trend of how much people are using edge devices, and therefore also how much people are experimenting with edge devices, right? It's a very important thing. And we'll see how that balance goes, but it's fascinating to think that one day we might have more devices outside than inside, and that places like the Texas Advanced Computing Center, which is a partner of Chameleon, or ALCF at Argonne, which is where our hardware are located, they're both top 10 supercomputing centers worldwide, that they may be dwarfed by the investment in edge devices on the outside. So the next question, can you elaborate on the eligibility for using G at Edge? Everybody's eligible. If anything, we want to be more inclusive than we are right now with Chameleon. I don't know how to do that because we are as inclusive as we possibly can be. Because again, we are motivated to see as many different experiments as possible. Jason was talking about how to create a project on Chameleon and so forth. Just to clarify, the PI eligibility requirements, they are not very strict. You essentially have to be a professor. You can be staff. You can be staff at any kind of research institution, and you can be PI if you're that, right? So essentially, I would say that pretty much only students cannot be a PI on a Chameleon project, right? And to clarify also, this is being a PI on a Chameleon project. So if you go to our website, if you press that big orange button that says Get Started, it guides you to a web form which tells you how to apply for a Chameleon project. And it's essentially, you just give us one paragraph of text that describes what research you're doing, and it gets reviewed by Juho, who is on this call, within 24 hours, generally speaking, right? So, and that's how you get access. So it's really, the requirements are not significant. Once your project gets approved, you can add all the students or all the researchers in your group to that project. So also to clarify, Guilherme, you are PI eligible, so you should be able to go and create a project and add everybody in your group. And do you have an intention to open up the platform for quick experiments without the need for an official PI? This is not going to happen. We actually thought about that for purposes of reproducibility, for example, where anybody could reproduce somebody else's project. The kind of project structure, where there's a professor or there's a senior person who takes responsibility for students who are added to the project, is ubiquitous across various academic infrastructures and is partially mandated by NSF, right? This is how it's done. But I think that, if you're part of any kind of research unit, there should be no problem to get access. And again, I mean, if you're a student, send your professor, send your advisor one paragraph that describes what research project you're planning to do. Have them go through the 5 clicks that it takes to apply for a project on your behalf. Okay, and we have another question from George Papadimitriou. Are there any plans for SDN support on the edge and stitching? Jason, do you want to comment on this one?
I mean, I guess the short answer is there are no plans, but that doesn't mean we don't plan to do it. It's more of like, so I think that it kind of depends on what is meant. One thing to note currently is that the way that most of the networking works in the edge platform, a lot of the traffic is sort of centrally brokered through the virtual site. That's how some of this stuff is possible. So I would be interested to know what exactly is meant by stitching in particular. Like, is it enough if a virtual central site has connections to, for example, Fabric that allow you to, yes, you can hook up your edge devices. They can get to Fabric, but they might not have like a closer backbone connection or something. And with SDN, that's also, I don't know, it's something that we can definitely look into, because the main thing is that, as Kate said, we're kind of trying to put out something that's an MVP and sort of see like what is the really important things that we should focus on. So we have built SDN capabilities in our bare metal sites. And sure, that's something that we could be working on the edge as well. So yeah, I would say that we don't have concrete plans right now. Like we're not going to like start working on it immediately, but it's not out of the realm of possibility by any means.
It's definitely something that would be good to support in the future. I think that Jason hinted that there may be a bit of a last mile problem with SDN specifically, but we're also working very closely with in other words, your edge device would have to be in a specially configured network location. We're working very closely with the Fabric team. We've got partners in Chameleon who work with networking, and I am sure that they would be interested in addressing interesting connectivity problems with edge devices. And so if you have that need, please talk to us. We'll try to find a solution to support your experiment today, and it may not be seamless, but then that will probably inspire what we do in the future with Shared Edge. So we would be very, very appreciative if somebody comes with a problem like that. More questions? So we've got a couple in Q&A. We've got nothing in chat right now. Does that mean that everybody is busily reserving their devices and getting into trouble with Jupyter notebooks? Okay, if there are no more questions right now, we appreciate, we've got another one that just popped up on chat. Let's see. So the question,
it's asking about the Google group link. And yeah, I think that we'll, I think last time we sent out the recording of the webinar over that Google group, if that's correct. I imagine we'll do that again. So if people were not able to attend, you can watch and catch up.
That's right. And also I would say if you type chameleon-edge-users into Google, it takes you straight there. So it should be easy to find, and we'll be posting announcements in that place, because obviously its infrastructure is a project that is going to be changing almost on a daily basis, and we'll just keep posting updates, so watch that space. Okay, if no more questions, and we appreciate all of them, if no more questions, we're going to thank you very much for your attention. We will have another webinar on Tuesday next week in a sort of more European friendly time at 10 a.m. Central, if I remember correctly. And of course, we invite you to come to that one. The contents are going to be roughly the same, though by that time we may have the NVIDIA Nanos online. So that's probably going to be the one difference. All right, thanks very much. Bye.
Thanks.